We can also use frames to address the Raven's matrices problems that we have been talking about all throughout this course. In fact, as we do so, we'll note another interesting fact. Frames and semantic networks are closely related. So let's do this problem. Here was a particular image, and here was the semantic network for this particular image that we had come across earlier. I could rewrite this semantic network in the language of frames by first of all building a frame for each of the specific objects. So I have a frame for X, a frame for Y, and a frame for Z. So here are the frames for the three objects, X, Y, and Z. Let's look at the frame for Z in more detail for just a second. So here are the slots. The name is Z, the shape is a circle, the size is small, and it is filled. You can see it here. We can also capture the relationship between these two objects. So let's consider a relationship example. Here Y is inside X, Y is inside X. We can capture that through the slot for the object Y. Here is the slot inside for the object Y, and it is pointing to X, indicating that Y is inside X. Note again the equivalence between the semantic network and the frame representations, the three objects and the three frames corresponding to three objects. The relationship between the objects and the relationships being captured by these blue lines here between the frames. While we can capture relationships between frames through lines like this, where one frame points to another frame, we can also capture them more directly by actually specifying variables or other frame names. So for example, for the frame Y, we might say inside X, which captures the same idea that we were capturing by drawing a line between them. In fact, this is the notation we'll use for the rest of the exercises in this lesson.